Okay, so today is the day we are going to be learning about balancing equations. So we're going to be taking our regular written equations that we've been doing and we're going to start balancing them. And we have to balance them because of the law of conservation of matter. So the law of conservation of matter tells us that matter cannot be created, it cannot be destroyed, it doesn't go poof out of nowhere, right? It has to be atoms that are simply rearranged. There is a finite amount of matter that we have, and we just rearrange it, and that's how we get things into different forms, okay? So what chemical reactions show you is how those atoms are rearranged. And you have to balance it so that you have the same number of, hydrogen atoms before the reaction as you do after the reaction, okay? So what you need to be able to do is show that the atoms are changing order, they're rearranging, bonding to something different, and there's at least one type of each atom on both sides of the equation. So if you have nitrogen in the reactants, you're going to have nitrogen in the products. Okay, and you're actually going to have the same numbers, but they might be split up differently. I'll show you a little bit about what that means as we go through. So the way that we're going to go about doing our balancing equations is going to be by doing an atom inventory. So let's think about what the word inventory means. Some of you guys work, so an inventory might be where you count what's happening in the store, okay? So if you work at Staples and you do an inventory, they're going to ask you to count how many binders do we have, how many pencils do we have, how many computers do we have, and you write down on a sheet and you make a record of how many you have. That's the same thing that we're going to do when we look at our equation. We're going to count how many of each type of atom do we have. How many of each type of atom do we have in the reactants and in the products? All right, so let's give it a whirl. So the first thing that we have is we've got our reaction. So we've got nitrogen gas reacting with hydrogen gas to form ammonia, okay? So first thing that you're going to do, you write out your equation, okay, just like this, and then you're going to write a list of the atoms that you have. I only have two atoms here. I've got N and H. So we write those both out, and then we're going to count how many you have on each side. Remember, you're going to have an N and an H on both sides for the reactants and the products. Something that's important is you want to make sure the N over here is lined up with this N here. If you flip-flop these and put the H first, it's going to be hard to look between and compare. So you want to have it lined up N, N, H, H, okay? Everything in a row. If we look at our reactant, we've got nitrogen, we've got two of them. There are no nitrogens in the second reactant, so there's going to be two nitrogens. We've got two hydrogens. Okay, now we move over to our products. Here, there's nothing written here, so if there's no subscript, that implies one, so there's one nitrogen here. And there's three hydrogens. Okay, so you can see if I compare this, two nitrogens, then to one nitrogen, nitrogens can't disappear. So we're going to have to balance that, okay? And what we're going to do is we're going to add coefficients in front of each reactant and product, and that's going to be what uses our multiplier that will help balance that out. Okay, so the coefficient is that multiplier. It tells how many molecules of a reactant or product is in the reaction. So in order to count, you're going to multiply the coefficient by the subscript. So if you look on the bottom here where I've got chlorine here, this is a coefficient of 2, and there's a subscript of 2. So there are two chlorines that look like this. So each Cl looks like this. It's two Cls. But there are two of these molecules. So there's a total of 1, 2, 3, 4 Cls right here. Okay? So what you need to do is you multiply the subscripts by the atom, and then you need to multiply the coefficients, just like you multiply the coefficient in math class as well. All right? Okay, so here we are. We've got our atom inventory started. We have our initial amounts. So what we're going to do is we're going to see how can we balance out that first atom. So nitrogen is 2 in the reactants, and there's only 1 in the products. So we're going to multiply the NH3, that whole atom, by 2 by putting a coefficient in front. When we do that, we're going to have 2 nitrogens and now we're going to have 2 times 3 from the hydrogen here. We're going to have 2 times 3 to get us 6. So let's look at that. Okay, so one more time, we've got 2 times 1 is 2. 2 times 3 is 6 here. So we just cross out our original counting and we have our new counting. All right, always recount everything. All right, now let's try the H. Okay, so your your nitrogens are balanced out, but your H's are not. So now I've got only 2 hydrogens in the reactants, and I've got 6 in the products. So what I'm going to have to do is I'm going to add a coefficient in front of the H2 gas to get 6. Well, it's H2, so I'm going to need 3 of them. So I'm going to use my coefficient of 3. So you can see right here, 3 times 2 is going to be 6 H's. And you're just going to cross out what your original counting was. Okay? So the last step that you want to do is recount everything. So I have 2 times N times 1 is 2. 3 times 2 is 6 H's. Over here, 2 times 1 is 2 N's. 2 times 3 is 6 H's. So everything is balanced out and it looks good. So here's a basic visual to give you an idea about what are we looking at, okay? So remember that a subscript talks about how many atoms are bonded together, okay? A coefficient tells you how many of those molecules are there, okay? So if you look here, I've got 1, if it's implied, it's 1, N2 right here in the green. And I've got 3 H2s, 1, 2, 3 H2 molecules to start with. So now they get rearranged, okay, this ends, they split up, okay, and get joined by some H's, and they form 2 NH3 molecules. So the N's, there's 1, 2 of them still, and the H's, there's 1, 2, 3, 4, 5, 6 of them still. So that's kind of a good visual of showing it's just rearranged. There are still 2 N's on both sides, there are still 6 H's on both sides, but they just form a new compound. They form a new compound. And that's it for balancing.